I'm really excited to join you all remotely here today. So I'm the behavioral science lead at RARE's Center for Behavior and the Environment. And we're set up with the mandate to really take research from behavioral science and translate that into content and tools which assist environmental practitioners. And the topic today really sits at exactly that nexus between science and practice. So diving right in, we've seen behavioral science theory be integrated at various parts of this crude depiction of a program lifecycle. So various groups have been working on how to mainstream behavioral science theories into program development. In fact, you'll see a fair amount of that work in the other talks in the symposium. And when a program is developed based on behavioral science theory, it allows you to construct what we call a psychosocial theory of change, where you can explicitly tie program activities to program outputs, and through explicit statements about changes in the prerequisite psychological and social states. That means you can say this activity is expected to lead to this change in psychological or social state, which is expected to lead to this behavioral output. And having this sort of psychosocial theory of change can be critical for integrating behavioral science into the last component of this graphic, program evaluation. By knowing what the psychosocial glue is between the individual components, we can evaluate programs against changes in those psychological states. This is what we need to build evidence around the underlying mechanism of a behavior change program. It's critical for understanding whether a program will generalize to a new context. But this got us thinking. Behavioral science is integrated into program development, and at least at the cutting edge, it's being integrated into program evaluation. But what about program implementation? Now, obviously, when it's integrated into program development, that changes the content. But how can behavioral science inform how we do program implementation? When we started digging into this, we realized that the key answer is how you do monitoring. Now, traditionally, monitoring primarily involves looking at what specific activities were implemented and making decisions based on that information. But what if we brought behavioral science into the mix? What could we do if instead of just monitoring our delivery, we monitored in real time the psychological and social state that a community is in? What would we do differently if we had that kind of information? Well, it turns out quite a lot. We call this sort of live monitoring of the psychological state of our target audience, and then using that data not for retrospective adaptive management, but to inform real-time delivery decisions, dynamic programming. This means decisions like what program activities should be delivered, to whom, and when. We see dynamic programming as being made up of possibly two things. The first is having a clear psychological theory of change for our program. Not as vague as saying something like, we use the theory of diffusion, but rather having identified how specific elements of the program are hypothesized to change specific beliefs or preferences, which then result in changes in behavior. The second is using technology for pulse monitoring of a community, where any given time, the program implementer knows where the community is at on key indicators representing those target psychological states represented in the psychosocial theory of change. Together, these outputs allow for the development of a dynamic programming flowchart of sorts, telling an implementer how to adjust their program live as the data comes in. So I recognize this is super abstract, so let me dive into a case study to show you how we're taking this up into the field. So RARE's Fish Forever program works on fisheries management, working with over 200,000 fishers in 250 communities in 10 countries across 4 continents. Fundamentally, it's a social norm shifting program, working with communities to help them move from unsustainable fishing to sustainable community-based management. Now, Fish Forever is integrated into various levels of change, from the national government down to working with individual fishers. For the sake of this talk, I'm going to be concentrating on Fish Forever's work at the community level, specifically helping communities shift to a social norm of respecting reserve areas. Now, the psychological theory of change for Fish Forever is based on 2 behavioral science theories. Social norms theory, primarily developed at Penn Social Norms Group, and the cooperative behavior checklist developed by the Applied Cooperation team at MIT. Fundamentally, the psychological theory of change for Fish Forever draws on these behavioral science theories to identify what beliefs need to change, and in what sequence, for a community to shift to respecting the roles of an MPA and not fishing in the reserve. The first belief that Fish Forever targets is believing that not fishing in the reserve is the right thing to do. The second belief is the common knowledge that everyone else in the community believes the same. Together, these two beliefs constitute the phase we call generating collective demand. At this point, the community itself is demanding the change. Just because the community is ready to change, that doesn't mean they will. This is because people are conditional cooperators. They're only going to change if others are doing the same. This means the next belief to change is the common knowledge that everyone is changing at the same time. We call this step of coordinating the shift in behavior, as entire communities need to move collectively to the new equilibrium. However, just shifting to a new equilibrium is insufficient for lasting change. There are other beliefs that are needed to strengthen the norm to ensure it's sustained. The first is about observability. If people believe others in the community will find out if they fish in the reserve, they're more likely to comply. The second and final belief is about excuses. The community needs to believe that someone is caught violating the rules. There isn't any excuse they can give that the rest of the community would accept. These two beliefs constitute the final step of the norm shift process, the strengthening of that norm. When changed in this sequence, we expect sustained cooperative behavior. In this case, not fishing in the reserve. Now, I know that's still pretty abstract, so to give you a quick taste of what that looks like, in generating the collective demand step, we do activities like the fish game, where fishers and other members of the community can really feel how they as a community would do better without fishing in the reserve. Just as importantly, they can discuss with the other members, really building that collective demand for change. Once they get to coordinating the shift in behavior, we need everyone to believe that they will be all shifting their behavior at the same time. This is accomplished with activities like public pledges, where before the entire community, fishers pledge not to fish in the reserve. Finally, we have strengthening the norm. One way this is done is through community-based monitoring, where community members observe the reserve area, ensuring that if anyone were to fish there, the rest of the community would find out. So you can see how the psychological theory of change maps on to Fish Forever. But how can that be used for dynamic programming? That's to say, how can we use live monitoring of these psychological states to improve program delivery? Well, as you can see, these beliefs are expected to occur in a sequence, in phases. And it's critical that you don't move from one phase to the next too early. For example, no community will be ready to coordinate a shift in behavior if they haven't built that collective demand to do so. So how do we know when to proceed? Well, normally, we might do something like, let's do these elements each for 4 months. But why 4 months? Maybe some communities are ready after only 2 and others take 6. Dynamic programming can be used to make that decision of when to move from one phase to another. The aim of this is to improve both program effectiveness as well as reducing costs, as it ensures that a program doesn't fail because it moves too quickly, while also allowing those accelerated communities to move at a faster rate, reducing costs. So the logic of how this is actually implemented can be expressed in a flowchart. In the first box, we have the program activities associated with the first phase, generating collective demand. After implementing these activities, you then monitor the community's psychological targets for generating collective demand. For example, we might say that if 80% of the community believes it's wrong to fish in the reserve, and 80% believe that at least 80% of the other fishers believe it's wrong to fish in the reserve, then we've achieved that collective demand and are ready to move to coordinating the shift. However, if a program hasn't hit those targets, we then see if the program is behind schedule. If not, no problem. We go back to running collective demand activities. If it is, we do a standardized qualitative assessment for why the collective demand activities aren't working and revise them accordingly. By following this pattern for each phase of the program, we ensure efficient and cost-effective implementation based on our understanding of psychological theory. So this flowchart identifies what information you need for dynamic programming and how that information is turned into program implementation decisions. But it doesn't answer the question practically, how do you do it? So for Fish Forever, the answer is cell phone polling, specifically interactive voice response, which is basically robocalls. So we developed an IVR polling system which allows us to send pulse polls to community members every 2 weeks, tracking for each fish forever community where they are on each of these key psychological elements of the program's theory of change. So we're currently doing user testing. COVID has thrown quite a wrench in our testing plans, but we aim to test and scale the platform across the entire program in the next couple years. So we're excited both for the ability to apply behavioral science to environmental programming to improve the efficiency and effectiveness, but from a research standpoint, we're really excited to collect, from what we believe is the first time, this live psychological state monitoring data for real communities changing social norms. So what's next? Well, the Center for Behavior in the Environment is really a field building initiative. So as much as I'm excited about developing out this concept and platform with RARE's programming, we're really excited about helping others apply this concept to their own work. So if you want to chat about this, both in terms of how we're applying dynamic programming in Fish Forever, or how it might apply to other domains, drop me an email or hit me up on Twitter. Thanks, and looking forward to any questions you might have.